Hey guys, Mr. Klein here with the video explanation of my project, STEM Project 2 Reactions for Fun and Profit. You might be watching this because you're one of my students or one of my students' parents trying to figure out how to do this project. Or you might be a teacher who's having to deal with next generation science standards or the Louisiana science standards, and you're having trouble with MSPS 1.6, which is utilizing a chemical reaction that either absorbs or releases energy to do something. If you're in the state of Louisiana and want to know who the absolutely crazy person is who developed this science standard, hi, I'm the guy who wrote that science standard actually. And so just to let you know, I'm actually doing this with my kids, and it's perfectly acceptable from 6th to 8th grade. It's actually very easy. So let's go ahead and let's go get through an example and unpack some stuff with the way I do it in my class. So the project summary for my sheet with my students is this, that you design and construct a device that utilizes a chemical reaction to heat or cool a cup of water by at least 10 degrees Celsius from room temperature for 5 minutes of being activated. That sounds like a really impossible task, but it isn't really. Room temperature is 23 degrees Celsius, because I use Celsius metric in my class. That's 72 degrees Fahrenheit. So you need to drop it either down to 13 degrees, which is 55 Fahrenheit, or heat it up to 33, which is about 91. And so what you do is you use a cup, you fill up a cup of water, and we're going to heat up that cup of water through one of two ways. I don't have the objects. I don't have the objects for an exothermic reaction with me, but for an endothermic reaction, you can use citric acid, which is this stuff right here. You can use it for canning tomatoes. You can find it in the canning aisles at your department stores like Walmart and stuff like that, or a grocery store. And or you can order it online, like from Amazon. I can get 5 pounds of it for like $12, which is more than enough than what you need. Actually, for this project, this thing, which is about $2.75, $3, is plenty with some left over. And baking soda. Okay, so you mix these two, and it creates an endothermic reaction which sucks in energy. It requires energy to keep the reaction going and cools it off. So what I'll do real quick is I will get this, and it's very important that you mix it with water before you do it, because the reaction just doesn't work out real well. So what I have right here in the cup you see off to the side is a little bit of baking soda. Okay, and I'm going to scoop and drop all this stuff in here. Okay, and then what I'm going to do is I'm going to mix citric acid and water as well. So here's our mixture right here. Baking soda settles really, really quickly. Citric acid doesn't quite. And as you can see, it fizzes up. Okay? And as the reaction occurs, I know you don't have like temperature-enabled computer, smartphone, tablet device to feel it, but this is actually getting colder. And it releases gas. In order to heat it up, you could use calcium carbonate. Calcium chloride, CaCl2, which is used for melting ice, or also in damp rid. Okay, and so this stuff's cooled off really, really quick. So use one of those two chemical reactions to either heat or cool it off. Now, one of the keys for this project with this right here has to do with adjusting the amount. Okay, so you need to adjust the amount of citric acid and water and baking soda and water, and you might need to put it in order to cool it off. And you'll see with my parameters in a second. I give my students about 2-3 weeks for this. Originally, I gave it 2 weeks, but I decided after students having trouble to go out for another week for this. So 3 weeks, and we test it on a design or a pass-fail thing. So these are the design parameters I put for my project. So parents, I'm going to explain all this stuff right here. Teachers who are trying to figure out this project, I'm going to go through all this as well. So it must either warm or cool 250 milliliters, so 8 fluid ounces of water by way of an exothermic or endothermic chemical reaction. What you just saw me mix was actually an endothermic reaction. It cools it down. Or the calcium chloride. Calcium chloride, you just mix it with water, and and it heats up, and it heats up rather quickly. If you mix a lot of calcium chloride in water, you can get almost up to the boiling point of water. So you got to be careful with that. So the device must be activated manually by the user. And this right here, this thing right here, my parents, I know you're like yelling at me right now while I'm going over this. Why do you have to do that? Well, that's because this is an engineering project, and I want the students to solve this problem. And I'm going to have some examples I'm going to give you in a second for you to see what it's like. In other words, the chemicals must be left separate until the user decides to warm or cool the water in the cup. My idea is this, is that the students are building a device that automatically heats or cools a cup of water. So you can mix it together, but I want them to make a device that does it. And I'm going to show you some ways that you can do it that are really dead simple. The device must heat or cool the water within 5 minutes of being activated by the user, and it must be safe. Okay, as an engineer, safety and ethics and things like that are paramount for me. And here are the 6 guidelines I have for this, which are kind of the design limits for my device. 1, it must be sturdy and able to be moved like a normal cup or warming device. In other words, I want it to, I don't want it to be able to fall apart. It has to withstand use. I mean, at least a couple times without falling apart. Like, it doesn't have to be made of like metal, sturdy enough. I mean, if you want to go all out and build it, knock yourself out. But I'm not requiring that. The chemicals must be kept from making direct contact from user as well as the water in the cup. Okay, this is a big sticking point, I know, for parents. They don't quite, you guys are like, I don't quite know what you mean by that. So I need some clarification. Well, I'm going to clarify it for you right here. So the idea is this, is we have our cup. Okay? And in our cup is the water we want to drink. And the idea is this device is going to heat or cool up this water for us, and we don't want the chemicals to touch the cup, because after all, if you heat up the cup of water and like the chemicals, by the way, the citric acid and baking soda gets really, really sticky. So you don't want like the chemicals to touch the cup, because then you can't like use the cup or use the water or something like that. So you need some way to protect the cup of water that you're heating or cooling from that. The easiest way to do this is to, in your device, have a second cup, and it fits right in. Okay, this is a second cup, and then this right here is the cup to cool, to heat or cool. Okay, so when you put it in there, when your chemicals react, okay, they get all over this outer cup and not the inner cup. Okay, so it's as simple as that. You just stack them. You have one cup and then you have a second cup, and it works just like that. Okay, so that's what this means right here. Okay, make direct contact with the user. You don't want these chemicals you saw from the fizzing and stuff. You don't want the person using it to touch that. So you got to keep that stuff in mind. Okay, the chemicals must be contained by the device. In other words, they can't leak out of the container. That comes with the first thing. Next one, device must be insulated from the outside. That's something as simple as foam or whatever material you make it out of. And any gas byproducts, which you saw the fizzing and stuff, as gas being released, need to warm or cool must either be contained by the device or safely vented. In other words, you got to have somewhere for that fizzing to come out without like expanding or breaking it. That's really, really simple, and I'll draw an example from there. So these are my design parameters. Now that you kind of understand this, I know you're really stuck. I know a lot of my parents are really stuck on this, is the device being manually activated by the user. Okay, I don't want my students just to like take a cup of each and just pour it in there like you saw in the video. Okay, I want it to be like a device that kind of operates. So here's some examples, and I'm going to show them to you. Here's example number 1. Okay, and let me zoom in. There we go. And let's look at this. So this is my first idea for a device. This right here is our container, which, by the way, the materials you can use are cardboard or foam board, like the foam project boards. And then I covered with duct tape, which you'll see in the next video I'm going to make with my example, okay? With duct tape, okay? Because that makes it waterproof. So you could use plastic. I've had some students talk about making plastic containers and just cutting out like dollar store plastic tubs and gluing them together. You can do that, or you could just get foam board and cover it with duct tape. So what we have is we have a device, okay? This is the box. And we have two sliders right here. And as you can see, here's my cup within a cup design. And this could be held up with like bamboo skewers, tape, whatever. Which, by the way, this is not drawn to scale. So the user has to manually mix the chemicals. So just for instance with this, I have my citric acid and baking soda. So let's say citric acid and water is here. Baking soda and water is here. Okay, I want them to mix in order to cool off the water in here. So the user has to activate the device. The user has to do something for the chemicals to mix. Well, what I have right here are two foam board covered with duct tape walls. And they sit there, and as you can see, it keeps the chemicals separate from each other. So the way the mechanism works is this, is whenever I say turn on the device, the user grabs and lifts up these. They doesn't have to pull them all the way out. It just pulls them up enough. You can put it halfway up, where then the chemicals come in and they mix. Okay. Now you want the amount of chemicals you have in here enough to come a decent height up. So you're gonna fill this more and have this cup lower to the bottom. Okay. So they come in and they mix, and it either cools it off or heats it up. Or you could put the calcium chloride down here at the bottom. Okay, and you can have the water. You lift it up, the water comes in and mixes, and it does the same thing. Okay, either way. But as you can see, the mechanism right here, when this lowers down, it blocks the two sets of chemicals that mix, and then all the user has to do is lift this up. They don't have to pull them all the way out. They just have to lift it up like a drawbridge. Okay, so it could just go up enough to let the chemicals in. Okay, so this is idea number one. Okay. This is idea number one. This is the lift device. So this one's dead simple. This gets it done. The user activates the device and the chemicals mix. The second idea is the one I have with my device, which I tried to make it a little more complicated just because I kind of wanted to do that. And it involves a trap door. So once again, we have our device. I'm using foam board wrapped with duct tape. Okay. And I have my open area, my cup's in the middle, and it's held on the walls and things like that. But what I have two trap doors. And what happens is the same thing as what you have right here. Okay, the user lifts up. But what I have on my device right here is the fact that you pull these out. When you pull these to the side, these chemicals come in and they mix and they fill up in this container. And what I did was I have a side wall right here that all I did is I glued it. I glued it in, or I used caulking. Okay. Caulking is a good waterproofing tool. To be honest, I just poured it on a popsicle stick and I just kind of roughly painted it on. It doesn't have to be very complicated or well done. It just needs to be watertight. And another thing I did was I took right here is plastic from a soda bottle, okay? And what I did right here was I caulked it to the walls because it keeps the water from coming through. This is a possible leak spot, okay? And so what it does is, because this is glued to the wall, this becomes a caulk to the wall. This becomes like a watertight seal, so the water doesn't leak back and out of this. Okay, so this is a kind of a safety precaution. I did this. If you feel a little frisky and want to try it like this, go ahead and do that. But, you know, work your way out of there. And it's actually really, really compact, as you'll see in my next device. Now, another one, the third idea that I wanted to show you guys, because people were mentioning this as an idea, is a little bit different. So what I have right here is we have our box. And we have like two bottles. These could be, for example, you can have a soda bottle and you cut this off. where it comes right here and you have your bottle cap. Okay, so the liquids come here and it comes out. What you could do is you could create a device where you have these and you put your chemicals. You could even put the powdered calcium chloride, and you can have the water, and you can do the same thing. Okay, so we put our chemicals, for example, my citric acid and water, my baking soda and water, right here and right here. Okay, so it sits there. You can get those surgical knobs, like for tubing and stuff, those teeny tiny little knobs that open. Okay, and you can put the tubing in here where it opens up into the area. You turn the knob, you turn the little knobs right here, which opens up the valve, which makes it flow in. Gravity does the rest. It pulls them all there, and it mixes. Okay, that's perfectly fine as well. So I kind of went up from complexity, where something is as simple as this, where you have two pieces where it's pulled up, okay, and the chemicals come in and they mix. We get a little more difficult, a little more complex, where you have two sliders that pull this out and the liquids come in. And then we go all the way to having like, well, maybe if I'd leave the page, there we go, where you have knobs and you have things like that turn the faucet and it pours it in there. Okay, and does that. Now, one of the guidelines for the project is to make sure that you don't have any that you can safely vent the chemicals. If you saw what I had earlier, this right here, you could do something similar. For example, so you have your box, and I'm just drawing a top view of your box. And then you have your cup. This is where the other cup comes in with the water. Okay, and chemicals go here, and they go here. Okay, if you use the cooling device, as you saw, you had the fizzing and the gas bubbles. You might want some way to keep it. You might want to put a lid right here, and you might want it to vent. Well, what you can do is you can create a vent, super simple, which comes up and has holes in it where the gas bubbles go out. Now, how do we build this? Well, what you can do is you take a soda bottle, okay, this part, the neck, especially a 2-liter one, and what you do is you cut off and you leave the little neck out. And what you then do is you could either use a nail or you can use a drill with a teeny tiny drill bit and poke holes here and on top, okay? And if you're really careful and you leave the screw intact in the bottle, what actually happens is whenever you go to use it, you just unscrew this, okay? And it'll vent out, and even if any fizzing, it won't actually come out of this. So the bottle cap actually keeps it in there. I won't have an operational one on the video I'm going to show. I just have like a proof of concept I want to show you guys. And so you can use that. You could use any other things. You could use one of the squirt bottle caps and just lift it up and it does something similar. Or you could just control the amount to where it doesn't fizz out. That's up to you. So, there you go. That is the summary for my project. Okay, once again, we want to do 10 degrees Celsius in 5 minutes, and we want to create a device that the user has to activate the chemical reaction. So we don't want them pouring it in and just letting it happen. So they can pour the chemicals in, and then they turn it on, okay? So they can do that in one of several ways. The easiest of which I'm going to show you again, is this right here. You build this out of cardboard or foam board covered with duct tape in order to keep it waterproof. You put 2 sliding lift gates right here. You put the cup of your water in right here. You mix up the chemicals. You pour them in. You keep them separate. And then when it's time to turn on the device, you lift these up. And the chemicals come in and they mix. And the chemical reaction occurs. And it cools off the water 10 degrees Celsius within 5 minutes. And you created something really, really cool. So there you go. That's the project. And you'll have that. for those of you who are not in my class, and if you're teachers and you're interested in this, I will have in the upcoming weeks, I'll have, once this project's complete and we have all our lessons learned and stuff put together, I'll actually have a project on my Teachers Pay Teachers page. Just look up my name on there. You can find that. Science stuff, social studies stuff as well. And all the information for this project will be for sale. If you always have any questions, as always, please let me know. You can drop one in the comments, and I'll try to answer them. And if, as always, once again, if you have any questions, please let me know, and thanks for watching.